This is number 17 on the sample final. If 95.10 grams of AlCO3 are reacted with 59 grams of H2SO4, how many grams of Al2SO43 are formed? This is a straight up limiting reactant problem, and it's telling us that we have 95.10 grams of AlCl3 and 59 grams of H2SO4. It wants to know how many grams of Al2SO43 can we form. There's two ways of going about this. There's the product method and the reaction method. The reaction method is to figure out how much product, the reaction method is to figure out how much of each reactant is required to make product. So quickly, if we have 95.10 grams of AlCl3, you got to figure out that the molecular weight of that compound is 133.33 grams per mole. And the ratio is 2 moles of AlCl3 reacts with 3 moles of H2SO4. And 1 mole of H2SO4 you'll have to figure out with your table weighs 98.09 grams. Oh, forgot my mole here. So this works out to be 104.9 grams of H2SO4. So this amount of H2SO4 is required to react with 95.1 grams of AlCl3. We only have 59 grams, which is less than 104.9. So that would tell us that our limiting reagent is H2SO4 and our excess reagent is AlCl3. You then use the limiting reagent to figure out how much product is formed, because that is the one that dictates how much product can be formed. So you take your limiting reagent, which is 59 grams of H2SO4. We already said it weighs 98.09 grams per mole. The ratio for our product is 3 moles H2SO4 for 1 mole of our product Al2SO43. And then you got to figure out with your table that the Al2SO43 weighs 342.17 grams per mole. And that guy ends up equaling 69 grams. So that's how we do it with the reactant method. The product method is different, and I'll go through that as well. Let me do some massive erasing first. and we'll start over. Now some of you guys prefer to use the reactant method. Some prefer to use the product method. Both ways are okay. At this point in the course, you don't want to switch the method you've been using so far on how to do these. You want to keep the one you're used to. I prefer the product method myself, which is the one I'm going to do right now. So in this case, you start with both of them, both the reactants, and you figure how much product is it going to make. Whichever one makes the less amount is going to be your limiting reactant. So we have 95.10 grams of AlCl3. It weighs 133.33 grams per mole. The ratio is 2 moles of AlCl3 for 1 mole of our product, Al2SO4 and then 342.17 grams per mole for our product. So our AlCl3 will make 123.8 grams of Al2SO4. And you take the other one and run it through. 59 grams of H2SO4. The weight 98.09 grams per mole. The ratio is 3 moles of H2SO4 for 1 mole of our product. And then the last step is of course the same. It weighs the same. And that one works out to be 69 grams, which is our answer we found the first time. Now either way you're going to be doing about the same amount of calculations. It's just a matter of what you're more comfortable with how you do it. So this here is the reaction method. No, this is the product method, excuse me. The reaction method was the first one we did, and this is number 17 on the sample final.